So let's talk about common ion effect. The common ion effect is the shift in an ionic equilibrium caused by addition of solute. So caused by the addition of a solute that takes part in equilibrium. That takes part in the equilibrium. Okay. Now we are going to define buffers. What is buffer means? Buffers. A buffer solution is characterized by the ability to resist changes in the pH. To resist changes in pH when limited amount of acids acid or base are added to it. So that's buffer. Now we need to find how this buffer made up. So let's talk about buffer, how they are made up. Main characteristics of buffer is what? Resistance change in pH when you add limited amount of acid base, and that's where they resist the pH. That's the buffer. Now let's see how they are made up. So a buffer is made by combining a weak acid with its conjugate base or a weak base with its conjugate acid. So that two pairs they are made up. So that's buffer. Now how do we solve the problems with buffer solutions? So there is a strategy for that. Solving problems with buffer solution. So what is? So first we have original buffered solution. So original buffered solution. Solution pH. And when you add H plus or OH minus, then you get modified pH, right? Modified pH. So what you do? First step, step 1. First you need to do stoichiometry calculation. Stoichiometry calculation to determine new concentration. And assuming, we need to assume, sorry it's going out of the box, assume reaction with H plus or OH minus goes completion. So that's the first step we need to do. And then second step we do, step 2, we need to do equilibrium. Equilibrium calculations. And then you can find modified pH. So that's buffered solution calculation, solving problems with buffered solutions. Now, how does this work? So I'm going to draw that chart, and then definitely we'll take examples and we will work on calculations. Alright? So, let's go to next one. So again, original buffered pH, original buffer pH, original buffer pH, OH minus added, and final pH. Whenever you add final pH of buffer close to original. Why? Because even if you add small amount, buffer what? Resistance to change, right? So, what happened? Added OH minus ions replaced by A minus 1 ions, and that's how it works. So buffering means resistance to change in pH. So after adding, yes, their pH is, final pH is close to the original. So that's how it works. And one more thing, I'm going to go to the next slide and I'll show it to you again. original ratio of HA concentration to A concentration, A minus concentration. So that's again equilibrium concentration. So let's see. Original HA concentration divided by A minus concentration. Okay? And when you add OH minus, then you have final HA and A minus 1, and which is close to original. Now how that happened? So I'm going to write the OH minus 1 added changes HA to A minus 1. But concentration of HA and A minus concentration are large compared to the OH minus added. OH minus added, and that's why this pH final concentration is close to original. Okay, so that's the concept, how the buffering works. Okay.